So here's our second example now of using the quotient rule. And just by even thinking of the word quotient, again, what we're looking at here is a division problem with exponents. So kind of building off of what we did in our first video and first example, what we're going to see here is that this is the exact same thing as if I were to try and write this out in expanded form, or I could go ahead and solve by just using the rule saying that when we have the same base, we're going to just subtract the exponents. So I'm going to show it both ways. The only difference here between this example and the first example is that this one now has coefficients. And so what we're going to see here in a problem like this is that when I've got coefficients up front, I actually need to go ahead and divide those first. So the first thing that I know is 27 divided by -9 is going to give me a -3. And that -3 is now going to be in my numerator. Now what I could do is I either could have that negative right out front of the 3, or I could just put it out right in front of the entire fraction, because this whole thing is now going to be negative. Now the next thing that I'm going to notice here is that when I'm doing x cubed, or x to the third power, divided by x, since those are the same base, I can either just subtract the exponents again, or if we did it in expanded form, that'd be kind of like the problem above where we had our x times x times x in the numerator over x in the denominator. And remember, when we have anything in the numerator and denominator that's the same number, those are going to cancel and give us 1. So we end up getting x squared left over from the x's. And then when I have y to the 5th over y to the 2nd, remember, dividing the same base, if we just subtract the exponents, 5 minus 2 is going to give us 3. So I have y to the 3rd. What I'm going to notice now is that there's nothing left in my denominator, unless I did like a -3 over 1. But in that case, it's going to be unnecessary. And so this particular problem, this is going to be our final answer here. Another way, again, to show this would be if I had the original problem, and I separated that out into 27 over -9 is the first part, x to the 3rd over x is the second part, and y to the 5th over y squared. I could separate it out this way and then kind of show it in expanded form and just show that each of these three fractions, when I multiply all of the numerators together, I got this other numerator that we began with. When I multiply all of the denominators together, I would get the denominator that we started with. And so, again, by breaking it up like this, it might make it easier than when you're trying to simplify one thing at a time and then combining your answer all into one piece. So if we do that, again, 27 divided by -9 gives us -3. X to the 3rd over x, if we showed that in expanded form, remember, is x times x times x, all divided by x. And when I have the same thing in the numerator and denominator, they cancel and give me 1. And now this is 1 times x times x. So for the x's, all I have left over now is x squared. And then with the y's, again, if I were to show this in expanded form, this is like y times y times y times y times y, 5 of them, divided by 2 of them. And again, remember, same thing in the numerator and denominator are going to cancel and give us 1. So now it's 1 times y times y times y times y, which gives us y cubed. So hopefully these few examples kind of helped you out there. If you have any more questions, please make sure that you email me or ask me in class tomorrow.